Hello.
Yes, it is.
Why are the wetland sliders?
Just,
I just said
restoration
they
ecology,
died in
climate,
wild.
climate
They offered
species.
them any. I don't know how to make that State Street kind of analogy. Who's P again? Oops.
What's up with Bodie?
He's
I don't know.
He might be dead. I
I
haven't heard from him in a couple of days.
yeah, he must be dead.
Must be dead. No other explanation.
He's probably taking care of his chickens.
Mm.
But they're not making it.
He has so many chickens. Taking care of his chickens. He's out in the woods.
Eaten by his chickens.
MTV Live.
Maybe
Marina Rihanna?
not here.
It'd be a weird name.
Guy died.
A
That was like the only character.
Dude, nice.
Dan, we have to bring a writing utensil.
No, these are new work.
Yeah, that's what I looked before.
So sad.
Man. I know.
I use my own blood.
Jose, what do you mean by bring a layer?
Like sweaters.
A sweater.
Okay. No, he wants you to bring it around.
Okay.
That's funny. You answer to this. You have to answer.
It was in the book I read it, but I don't remember.
That seems dangerous.
What?
That the light's just floating.
Oh yeah. No, but those strings are made for it.
Floating right above his
Yeah.
You have part of the light floating right above your head.
I know, I'm not worried about it.
These little wires are made. Wow.
I know.
I know. I'm pretty sure you can see. That would hurt.
I can't even see what the actual light is. Oh, never mind, I saw it.
Yeah, it's just floating.
It's floating.
Don't hate it. It wants to float.
Wants to float its own boat.
I haven't done anything English over. What does that 3 points page have to do about?
All of chapter 1. Like
Summary?
1 through 13.
I read 1 through 4.
Oh, yeah. Summary.
What? It's like,
The Huck Finn summary.
I read.
I read. I read my notes. You actually read?
Yeah, I read like 43. I go on Swiss. Better than SparkNotes.
What do you mean? What?
It's like SparkNotes, but it's more detailed.
I'll check it out.
And yeah, that's what I use too. Better than SparkNotes. They like changed the build from last year. Yeah. It's weird. Last year was like really outdated. No, it was better, dude. There's so much easier than this one.
no, I wouldn't.
I don't know. No, this year it's all like
I
tech.
saw it. The color's weird. I knew it was mustard. The smell just helped me figure it out.
Samuel Gary. Okay, now everybody please take out your notes for the reading packet. I believe that's assignment 3.2. Cut into strips.
Alright.
You've got 2 separate jobs that kind of overlap.
Alright.
You'll need to confirm these classroom layouts or make changes. So for room 65, we have a total of 36 desks, and it's your job to count without any disturbance to the class if possible. 0 tables, 0 chairs in this room, and mine all face forward.
All right.
If you go to like room 205, it'll be 38 facing forward. Room 206 might have 1 table, and the chairs are half this way, half that way.
Right.
So you can make any drawings that you have to, like this, and say 16 to 16, whatever. Okay? But just let me know if the room number, desk count, table, and chairs orientation are accurate. If not, make changes. If it's accurate, you just put a check mark.
All right.
Okay?
And then so for the blank ones, so I just, oh, okay, no, never mind.
Those are going to does that tables and chairs.
All right.
But the ones I need you to do very first out of the whole main building
Oh, ones that,
are the ones that have a little slip.
right.
If they have 36 desks, give them a slip. If not, correct and bring me the slip.
All right.
Actually, give them all the slip. Give them all a slip, and just tell me what, and just correct those first. Yeah, give them all a slip, but
And then correct.
correct them first. Then the rest of the period, do the other ones. Make sense?
Okay, bye.
All right. We have an awesome field trip planned for Monday. There's like 2 possible itineraries at this point. We're like negotiating our final access deals with like the places where we're going. But I think they're both going to be like, whatever you want, I don't care. They're both going to be like really good choices. The trip's going to be awesome, weather looks nice. You meet me 8:15 at the main entrance of the high school. We need about 15 minutes of paperwork and about 15 minutes of pep talk. The bus probably picks us up around 8:30, 45, because there are a bunch of like independable monkeys that run that company. As soon as the bus driver's done like snorting coke off the hood, then we'll get on, then we'll go on the road. No, seriously, like every one of the bus drivers is like the greatest people on earth. Like I've been doing these trips for years, and all the bus drivers are like super rad homies. And every time you have to deal with the office, like the drivers go like, "Oh god, I gotta call the office." And like when you call, they're like, "Yeah, I'll be right back. Just call you back. Okay, great, thanks." And it's like nothing ever happens. Okay, can you confirm that you guys are coming to pick me up in 5 minutes? Yeah, we'll be right there. I'll call you right back. Nothing ever happens. Like the office is horrible, so we'll see what happens with the bus. You gotta be patient. So we meet at 8:15. We drive out around 8:45. We get off the bus with our stuff and we start walking. We might have like a little shuttle from a bus in the middle of the day, like they might do a little hop and then they go away. You'll need to bring what it says on the board. I hope none of that is surprising to you. I want to be really, really clear about this because watch what happens on field trip day. You need water, food, because even though there's food all over Isla Vista and UCSB, we will not have the chance to stop and get that food. You got to BYO food and water. Like, we'll take a couple of bathroom breaks here and there, so you might be able to fill up with water. But, you know, it might be in, like, some shallow little sink where you've got, like, tap water in a bathroom where everybody's, like, poo on the faucet. Not a good idea. So you might want to just bring, like, a slightly larger water bottle so you don't have to refill.
So is that
Yeah, bro.
I'm focusing on the ones with 36 desks, right?
What?
I'm focusing on the ones with 36 desks. Yeah.
I said the wrong thing. So I should clarify. Ignore that thing about the desks.
Okay.
The first thing you do is deliver those slips, and for the ones with the slip, just make sure the information is either accurate or updated. Then once you're done with the slips, start with the other upstairs rooms, then the other mid-level rooms, and end with the downstairs rooms. Thanks. You'll need a layer because temperatures can go like this in Isla Vista. So even though we're going to be like really warm in the morning, they might be really cold or vice versa. So you want to have like a slightly modular clothing setup. You'll need some kind of sun protection, writing utensil because you might be taking a couple little notes on your half slip. And like, obviously you're going to have shoes. I just mean to say that it's not a death march, but it's like a 5-hour field trip where we walk maybe half the time. Like, they're little sections, like, we're not going to walk for 5 hours. But you do like a 20-minute walk and a 20-minute talk and a 15-minute walk and a half-hour talk and a half-hour walk and a 10-minute talk. So there's all these like little stages of walking. They'll probably pound out about 3 miles in the course of the day. It's not enough to like ruin you, but a lot of kids, like at the end of the day, they're like, I have blisters, I want my hoochie shoes. Like, you might want to wear shoes that you can like do a little bit of mileage. We cannot plan a water activity for this trip. But by coincidence, our lunch picnic happens to be at the beach, and we happen to have lifeguards attending. So if you chose to get your feet wet, I wouldn't say anything. And I'm going to bring trunks and a towel in case I fall in while getting my feet wet. And that's totally your call, but like, you know, if everything lines up right, it might be like, any chance I get, I swim in a natural body of water, and I've not got a chance, so I might take it. Just saying. Any questions about the field trip plan, 8:15 at the flagpole? How many of you know you're not going on the field trip? Every single one of you going on a field trip? I'm going to have the boredest days. Okay, cool. Now let's talk the reading packet. You can go whenever you want. Let's talk about that reading packet. The vocab had a couple of words that I want to talk about at the end, but does anybody have any questions on the first 4 or 5 words? Resiliency, inertia, constancy. Yes?
What does inertia mean?
It's actually inertia. I misspell that, and I've misspelled it every year for like a decade. So I'm sorry for that confusion. It is inertia.
What's competitive exclusion?
Competitive exclusion is when one species outcompetes others from a niche. Like the cane toad moves in and it's better at it, so it excludes others at the same niche. They don't have to be invasives, by the way. It's natural for species to turn over in their biomes. By the way, do you want me to define inertia, or do you know what that means?
I'm trying to forget.
It's the way that an ecosystem, the ability of an ecosystem to resist change, like it stays the same. And usually we say that.
It's not resiliency.
Yeah, very similar. Yeah.
Well, resiliency is like bouncing back out.
Yeah, recover.
Yeah.
Right. So inertia is like to resist change, and resiliency is to like recover from change. Roughly the same concept, but 2 different ways to look at it. Roughly the same thing. If there are no other questions, I want to talk about 2. Key issue comes up in ecology. We talked about this a while ago, and now it comes back in a different way. I think everybody here remembers that ecosystems don't have discrete borders. Biomes aren't obviously like now exiting rainforest, welcome to the savanna. You know how like when you cross a county line on a drive, it says now entering Ventura County? Like there's no line that says now entering rainforest. The savanna just gets a little wetter and a little wetter, and then you see a couple of rainforest species, but you still have mostly savanna species. Then you got a few less savanna plants and a few more rainforest plants. You guys understand what I'm saying by this? There will be like some rainforest stuff, it's kind of peters out, it's kind of blend and overlap. Check this out. Where the rainforest and the savanna meet, they'll have a little bit of overlap. Some savanna species trickle into the rainforest, some rainforest species trickle into the savanna. We call that area, please look up, where 2 ecosystems overlap. That's called an ecotone. Ecotone is a noun. And because you've got double the diversity, you've got some rainforest species plus some savanna species, that's twice as many species, that's called the edge effect. Ecotones are extra diverse. So a perfect example is an estuary where you've got like some saltwater stuff but some freshwater stuff. Because those two are in the same area, you've got some saltwater and some freshwater, then you get an edge effect, meaning you've got more diversity in an estuary than up the river where it's just freshwater, or out to the ocean where it's just saltwater. The estuary, edge effect, more diversity at the ecotone, the place where they overlap. Questions about these two vocab terms? Study those in the reading packet. Number 11, I made a handy little drawing for you. Check me out. Starting at the equator, heading to the poles, temperature only goes down. Rainwater drops at the deserts at 30, and then rainfall picks back up as you head toward the poles. Would anyone like me to clarify that little drawing?
Yes.
So is the black the temperature, and then the blue is the rainfall?
Correct. Black is temperature. So the hottest biomes are the poles. Sorry, that sucked. The hottest biomes are the equator. And those average temperatures go down as you get further and further from the equator. You can go north or you can go south. Temperature goes down away from the equator. Now watch me. Look, if we're starting here at the equator, this is almost exactly the equator right there. That's the equator, okay? Starting at the equator, as you head north toward the desert, temperature goes down. Sorry, rainfall goes down. Rainfall has dropped here. The driest band is 30 degrees. But then as you start to head north, it gets really wet again at the 60s. By the way, there's a little detail that I didn't add to this drawing, but in case somebody really wants to nerd out, like Nerd Patrol, rain actually drops again at the poles. The poles are very dry. But there's such a small land area that I didn't want to confuse the drawing too much.
Jose,
Yeah.
is this recording or do I need to press the button?
Well, I don't know. Is it recorded?
It has a little red recording button.
Bro, I don't know which way the buttons work, but if
Yeah,
not, do it.
Recorded.
That's recorded.
It's recording?
Blue's
Look
not
at the button.
recorded.
Look at the time.
Yeah, the time's going.
Oh, yeah.
So we are recording?
Yeah.
Thank you. I just don't know which
Red
colors
means
do what. Thanks for checking, though. That's awesome.
Yeah.
Okay. 12, I got nothing to say. 13, absolutely. Sorry, I ignored your hand.
For like 30 degrees.
Yeah, 30 degrees thing. I'm sorry.
Why is it like the U.S. is dry? It's like Northern Africa, like India, like all those. Why is it like stop at the United States?
So it's got something to do with the width of the land masses. So the effect of deserts picks up behind the rain shadow. And at the 30s, the United States is pretty narrow. So you've got, we do have desert, it's just a little bit greener. Our deserts are especially lush compared to those deserts. Because by the point where you start to develop arid air mass, you've already got some influence of the Atlantic Ocean's moisture. If the Americas were equally wide at the 30s as Africa is, for example, it would have roughly the same degree of aridness. We just have like too much ocean influence. We're like sandwiched by oceans at 30 to have like a big desert. Anybody else? Oh, there's mountains there. Anybody else? Okay. So number 13, I just love to think about this. The urban ecology concept. I think it's fascinating to think of cities as a biome. Just think about it. They're a distinct habitat type, all that concrete and all those like manicured landscapes. They have distinctive physical properties, like they have limited productivity, they have higher temperatures, they have a lot of surface runoff and minimal water storage. Cities are very much like a biome defined by their physical reality. You always know if you're in a city, right? You can see it from space. Cities are obvious. They're a lot noisier. There's a lot of dangerous moving stuff. And they tend to have distinctive ecological characteristics. Cities are basically biomes. Trip out on this fact. Let's talk about the productivity in a city. In the last 200 years, humans have impacted almost every inch of the planet's countryside. Right? We make farms, we cut down the trees, we suck out the water, we dam the rivers, we make big holes in the ground to remove our materials, we make other big holes in the ground to put our materials. Everywhere in our countryside, we've made ecological changes. We draw material from outside of cities and bring that into cities. And think about the ecological interpretation of a city. It's like a giant food disposal. We bring lumber, petroleum, water, rocks into the city, and we build, use, break, build, use, break, build, use, break, like a food disposal. And then we spread out that material inside the city as little dustings of like lawn clippings and wood chips and plastic bags and orange peels and dog poo. And so it would make sense that instead of like the native productivity of Los Angeles, there are now ecosystems built on that imported productivity, like cockroaches to pick through all of the leftover crumbs in your house, and ants to pick apart like all the wet spots in your foundation, and flies to lay their eggs in dead roadkill, and rats to pick through all the garbage left outside, and termites to eat all the rotting wood and construction debris piles and wet houses. And of course, if you have all of these insects that are specialized on our human ecosystem, then you've got like the predators that eat them. So like raccoons and skunks that are eating all of the mice and the rats. Do you guys know that the highest concentrations of skunks found in California is Laguna Beach? But the best place to find a rabbit is Laguna Niguel. The biggest numbers of red-tailed hawk concentration are all like right around Fresno. The healthiest populations of great horned owls are like in the Santa Ynez Valley and the San Joaquin Valley. Am I the only guy that thinks that's neat? That like cities have shifted, like humans have shifted biome ingredients and kind of rearranged this new biome called cities. I guess nobody else is impressed by this, so I'll move on, but I think you guys should, someday if you get bored, just like throw that down on your cell phone, like urban ecology. In the last 10 years, this is a totally new field, to start thinking of cities as biomes. And they have like really characteristic biome ingredients. We have like our own specialized trophic pyramid for cities. Did you guys know that the city of Laguna Beach had to spend something like $3 million on professional hunters to try to lower the number of skunks because it was affecting real estate values?
Why is there so many skunks there? Is there a reason?
We've created a niche for them. Yeah.
Is the like diversity, like the number of animals, like going down in like rural places, or is it just that it's going up in cities?
I think it's probably both. I
'Cause
think,
the animals are getting taken.
yeah, and it may not be so direct that they have moved. We've just sort of like taken out pieces outside of cities, and that's having one set of impacts, right? Like we've taken away the habitat for the bird because we cut down the tree.
So then maybe just
It's not like that bird now has a home in Los Angeles. As a separate parallel trend, we've transformed both. We've taken away niches someplace, and we've coincidentally built other niches. It's not for the same species. It's not like the woodpeckers now live in LA. But in the same way that we've erased niches in some biomes, we've created completely separate niches that benefit other species in our cities. Like the skunk thing. He says, why are there so many skunks in Laguna Niguel? Because cities turn out to be the best place for skunks to live. Especially if it's like a temperate city with a lot of landscaping and ice plant. Bingo. Like skunks are stoked there.
What about Iceland gives us an advantage?
I don't know, they like to build subterranean nests. So they like dig out holes. And there's a ton of ice plant in Laguna Niguel, so they get a lot of stuff to eat. And then like they have a place to build really safe places to hide. Nothing else can hunt them under the... So they just breed like crazy because they got all the food they need, a lot of dim lighting because of all the landscaping. So they just have like a perfect home.
They don't really have that much. Have any predators?
I would imagine not. I'm not really an expert on the ecology details. I just think it's super neat that we're like creating niches. Like you can't not make a niche, right? Like you're sitting on a sailboat and all of a sudden you've got a place for termites to go or seagulls to stand. Like, okay. I'm sorry that I'm so interested in number 13. This is the sort of crap that gets me really excited, but I don't mean to bore you. Number 14 is our warm-up and a key term. How many of you have heard the name Tony Blair, former Prime Minister of Britain? England? Yes. Okay. So he was like from the George Bush era. He was like the British counterpart. Tony Blair was probably what you consider a moderately liberal prime minister. I'm not really an expert on his political affiliations, but I think he was like a Labour-friendly liberal. And if I'm wrong, somebody correct me. I'm not really... Anyway. This dude, Tony Blair, had an interesting idea. He said, our government officials sure buy a lot of airplane tickets. We, the government of England, added up all those air tickets are flying like 1 billion miles a year. And of course, every time you move 150 pounds through a mile of the air, you're making a certain amount of CO2. So somebody did some math. And I'll make up a number. They release 1 trillion pounds of CO2. So what did he do about that?
You plan to donate to cleaner energy projects in developing countries?
Right. Now he got a lot of people made fun of him for picking the third world. They said it was like a political stunt. Everybody said, we've been asking you to do this in the UK. How come we can't do this back home? You're just hiding from the real political issues by doing it where it's cheaper in the third world. But politics aside, does anybody know what it means to offset an impact?
Shift it to somewhere else?
Yes?
It's to like when something's bad, so you do something good to even it out.
Right, to even it out, yeah. So because of a harm, you do something beneficial elsewhere. Now, in environmental science, this is a key vocab term. We're going to talk about this on the field trip. It comes out a lot during the class. So I just had to do this whole thing about Tony Blair as an example. His was a CO2 offset. The idea is we're making CO2 by flying, so let's lower CO2 by doing wind and solar. You understand what I mean by an offset? It's like, Mom, I wrecked the car, but I'll mow the lawn. In environmental science, that's called up here on the whiteboard that I'm showing the laser, mitigation. Mitigation is to offset a harm. And usually this applies to habitat. So if you're going to develop an acre, you should restore an acre. And there's a funny little detail. Are there any questions about mitigation first? Because I'm about to add a separate detail. Remember the warm-up, number 14, Tony Blair? That's about CO2, but I want to talk about habitat now. I want everybody to use your imagination. Just think about it. Just go with your gut. I don't expect you to be an expert. Hi, I'm Jose. I'd like to mow down 1 acre of chaparral to build a house. But I'm going to take that parking lot over there and turn it into chaparral. Do you think 1 acre of restoration is a safe offset, a fair balance for an acre of destructed native habitat?
No.
And why would you say no, not really? 1 for 1 isn't a good trade.
Well, there aren't already animals dependent on the.
That's right. What's an even simpler way to say what he just said? An acre of restoration does not equal an acre of habitat loss because it's not the same. It's not quite as good. Does everybody agree with me?
Yeah.
So for land, we have this concept called the mitigation ratio. The idea that depending on the habitat, depending on the impact, depending on the restoration, you don't go 1 for 1. Like at the Santa Barbara airport, they had to extend the runway. So for every acre that they took away in a really nice part of a creek, which was like critical riparian habitat / wetland, they had to restore 4 acres of estuary habitat somewhere else on their property, a 1 to 4 habitat ratio. Yeah.
Is that enforced by the law or like how do you
Usually there's a governing body that negotiates these contracts.
But it's not
So-
like 1 to 4 always in Santa Barbara? Or
No, it's not.
It depends on the situation.
It does, yeah. It's very circumstantial. And so sometimes, like, if you're going to build a house, you might tell the city of Santa Barbara, like, seriously, the acre I want to use is pretty crappy. Can I just give you like 1.5 acres that's really nice over here? And usually that might be a fair, that could be a fair trade. It's very situational, but the mitigation ratio is negotiated depending on the value of the impact habitat versus the quality of the restoration habitat. At UCSB, when they built Manzanita Village, which used to be a crappy old parking lot, they were like, look, the place that we're developing is really crappy. Let me fix up some other really crappy stuff. And their ratio was 1 to 3. Less restoration because what they were beginning with wasn't that valuable. Does that make sense to everybody? Is this working with the math and the ratios? I want to move on. We're going to talk about it a lot later. Okay. Number 15, I just have to tell you a fun story. This isn't really like clutch science. It is a neat example, though. Has anybody here ever fished for the northern pike? Great Lakes, Michigan, southern Canada? Has anybody ever seen northern pike? Oh, that's too bad. Northern pike are the freshwater equivalent, if you've seen them, of like barracuda. They are a very fast swimmer. They chase down small fish and then lunge at them. They're shaped like barracuda, so they're elongate. Like barracuda, they have very sharp teeth, but unlike barracuda, they have an even bigger mouth. Barracuda have like mouths like this, like now. Ever seen a barracuda? Northern pike has a mouth about twice the size relative to the body. So northern pike are like this. Really sharp teeth. If you want some time, you can YouTube northern pike eating baby ducks. Or northern pike eats seagull. Or northern pike eats birds. Northern pike are kind of burly. When they get really big, like 4 to 5 feet, they take out like mammals in the water, and like they could probably hit a chihuahua. I don't think they're any threat to humans unless you get them on the boat and they're flapping around with all those teeth. They do cut people up.
5 feet.
Yeah, I mean a 5-foot fish. That's like from me to homeboy.
Holy.
Austin.
Oh well, turn around.
Oh yeah.
Yeah, that's about 5 feet-ish. And so sometime if you get bored, take out your cell phone and check out these northern pike photos. They're like a really big-ass, scary fish. And if you watch them hunting, they're like quite powerful. They're a serious fish. And so fishermen love them. They have this really long shape, they're like elongate, which makes them very powerful swimmers. And because they're powerful swimmers, they're a lot of fun to fight. Like a 6-inch northern pike will put up more of a fight than like a 16-inch trout. They are native to the middle Michigan Great Lakes area. And because a lot of fishermen go there to catch them, they're like, dang, that was really fun. Now I got to go back to the Sierras and keep catching the same stupid trout. And seriously, for people who live in the Sierra, like you get to a point where fishing trout just starts to get old. Like I've been fishing trout for a few years and I'm already kind of like, yeah, all right. This is like, got the trout, kill them and eat it, fine. But like they're not, it's not really like crazy action. So check this out. The northern pike is first of all a highly adaptable generalist. They're really flexible about water quality. They're really tough. They can eat anything that's in the water. They'll eat amphibians, they'll eat snakes, they'll eat mammals, they'll eat mice, they'll eat birds that fall in, birds that are swimming, whatever. They'll eat anything. Number 2, they grow really fast and make a lot of babies. Number 3, they outcompete anything else in the water because they're so bloody aggressive. They'll kill fish that are bigger. I've seen photographs of a northern pike like this trying to swallow a rainbow trout like this. And if they just get into a showdown, they just go, arf! And they just like charge. They're just like bulldogs. They're super competitive. Finally, number 4, they fill a niche that's usually vacant in many freshwaters, which is a top predator. Most freshwaters don't have predators, especially in lakes. So you understand why I gave you that list of 4, right? This should sound familiar. The northern pike is a perfect invasive species. And it's a lot of fun for fishermen, so guess what? People release them in lakes to establish an exotic fishery. Remember I told you one of the reasons that invasive species get spread around is exotic introductions, where people just want to add something to their biome? You may have read about it in number 14. There's a little town called Porterville.
Oh, that's where I was this summer. Not right there, but like right above there in the Sierras. In the Sequoia, yeah.
Porterville or Placerville?
Porterville.
Porterville.
It's right below the Tule River.
Yeah, that's right. It's also right next to the Needles. There's like a big range of rocks up there, which is one of the most like famous and like hard man climbing areas in North America.
My dad was talking about that there was this one boulder like right at the top of this giant cliff, and it looked like it was pretty much off the edge of the cliff, but somehow it was still up there.
Yeah.
We were just waiting for it to
Really
fall.
big, columnar, yellowy with lightning.
Yeah.
Those are the Needles. I climbed there. It's
Oh, wow.
like bone crushing.
Yeah,
it is like utterly like you get so humbled when you go out there. It's all spooky and hard and like sustained, difficult climbing. It's totally crushes your dreams. Okay. This is Lake Isabella. This is the Kern River. And right around here, there's a couple of little reservoirs where people have released northern pike. the environmentalists go, these things are invasive, they're eating all the frogs, they're eating all the native trout, they're eating all the rare little birds, they're eating all the salamanders. We got to get rid of them. They spend like millions of dollars to exterminate the pike, and then 2 weeks later, they'll catch some fisherman that was breeding them in the garage to put them back out there. And they go, dude, you did it! You're going to jail! They're like, do all this lawsuit stuff, like stop the fishermen. Spend another gazillion dollars to go get all the fish out of the reservoir, and 2 weeks later, one of his homies is like releasing them back into the... And there's this like perfect conflict between, do I want an invasive because they're good for fishing versus do I hate an invasive because they're bad for the ecosystem? This is like the fundamental underlying issue, is how do we want to manage our resources in environmental science? It's just about opinions. For some people, it's like, quit killing my fish. These are fun. Anyway. 16 and 17 get 3 stars each. Key terms. So, keep in mind that in nature, there's really no garbage, right? We've talked about this, that decomposers sort of recycle things back into the food web. There are biomes that are specialized in decomposition, like wetlands, swamps, marshes, where these are biomes where you're always feeding them ingredients naturally that are just being decomposed and recycled. So wouldn't it be nice if we could use that living stuff to fix problems like our pollution? And it turns out you can. It's called bioremediation. There's 2 ways to do this. Either encourage the naturally occurring microbes, or number 2, add specialized microbes. You can't bioremedy all problems. You guys realize nothing in nature eats radioactivity and makes it non-radioactive. Nothing in nature eats glass or like spare tires. But as long as there is a living organism that will break down organic waste, we can use life to lower our pollution. So, key term. We're going to visit Manzanita Village at UCSB. When they developed the site, they had to do a mitigation plan. And one of the things that they added in exchange for developing the site, they added a fake stream. It's called a bioswale. These are man-made creeks where the plants are used to absorb nutrients out of the water, so you're not dumping all that runoff into the ocean. Even more so, by the way, if you all want to get a job, like straight out of college, get ready for this. It's like an exploding field. Now that we've run out of wetlands, we realize they're really helpful. So build fake wetlands. This is like one of the fastest growing fields in environmental science. It's actually really nice. You work outside with like native plants and greenhouses and like shovels, and it's kind of like nice sunburned, pretty places sort of stuff. Totally explosive field, building artificial creeks to use living stuff to fix runoff. What's the word?
Rio 2 wasn't there, I guess.
Okay.
Locked extras.
Extras. And you've edited?
All the edited.
Cool. Awesomeness. The ones that don't have any changes are accurate? Did you do all these other ones?
Oh.
So those are the. So now you go do the ones that you didn't give a slip. Got it. Okay. FYI, just for like nerd effect, there are a couple of specialized types of remediation that I want you to know. These are vocab terms later in the year. Please look up. Phytoremediation and mycoremediation, where you use plants to filter something out of the soil, or mushrooms to filter something out of the soil? Specific organisms have very specific metabolism. So for example, there are grasses that really soak up selenium. So somebody has like a chemical waste spill, and what are you going to do? Like, how do you get the chemical waste out of the dirt? Like, if you want to keep the dirt, what are you going to do? Like, you can't like pluck out chemicals, right? Or even worse, what if there's like a radioactive accident and there's like radioactive fallout? How are you going to get that out of there? You can't like pick out little pieces of ash. Radioactivity is like elemental, right? Everyone understands this? So what if I told you there are certain types of grasses that preferentially love to absorb selenium? Something weird about their fruit or flower or something, so they really like. They just spread out some seeds, water it, come back a few months later, mow it down, put it in a barrel, and all your selenium just got picked up by the grass. Or you go over here, there are mushrooms that preferentially absorb radioactive cesium, for example. So you inoculate the soil with those spores, you put a bunch of wood chips on top, and the mushrooms start to grow and eat the wood chips, and as they do, they soak up all of that cesium. Then when they fruit, you just like kill them, dry them, put them in a barrel, and you got all your radioactive waste out of the ground. I find this to be super cool nerdiness. So we call those phytoremediation when you use plants to bioremedy a problem, and microremediation when you use mushrooms to bioremedy a problem. These are that second type I was telling you about, very specific. You're introducing a specific species that's not necessarily native to do that one job. Is everybody feeling extra Friday today, or am I extra boring today?
Extra Friday.
Extra Friday? Okay.
The weather. Yeah. It's tiring.
I actually am kind of feeling it too, so I just wondered if it was just me or what. Okay. 22 and 23, I got nothing to add. I'm switching to, what time is it? Oh, I forgot, excuse me, forgive me. This is that renumbering problem.
It goes from 20 to 35%.
Movie questions, right?
Or 30. 35 to 37. We already went over those.
We already went over them? No questions about them?
Yes.
Yes?
Well, you said 3 stars, you said it to me.
Yeah, so the 3 stars were for the concept of bioremediation, and so like streams, for example, streams are especially good at soaking up nitrogen. And so that's what bioswales do, they soak up nitrogen. And so that whole concept of like streams filtering out certain types of pollution that are dangerous elsewhere, useful there, that's 3 stars. All right, so if we did do the movie questions, no other follow-up on the movie questions. 21 was the biomes, and I'm kind of sick of talking about them. So 22, nothing to add. Which assignment is this? 3 point what? 3.4? Do we have vocab on 3.4? It was super easy. Any questions about it? 'Cause I don't have